Hello everybody, my name is Mark. N9WIB is my call sign, and this is the Radio Signals podcast. This is the Technician License Series, and this is Lecture 2. In Lecture 2, we're going to cover SI units and unit conversion. This is going to be a relatively short lecture because we want to cover some examples and not necessarily get into what radio waves are in propagation and electricity just quite yet. I think we really need a basis before we kind of delve into that. So what are we going to cover in this lecture? We're going to cover U.S. customary units, metric units or SI units, metric prefixes, and basic units of conversion. I know that sounds exciting, but it is actually very interesting. So U.S. customary units are what we're all used to in the United States. So inches, feet, miles, and pounds are the typical units of measure we've utilized here for many, many years. This is based on the English units originally developed in the British Empire. However, the British Empire has obviously moved on to a more convenient method with the metric system. The metric or SI units, or the metric system, is used throughout the world with the exception of very, very few countries, the US being one of those. It is used in the scientific community, so actually based on that, the US uses two systems of measure. The customary system, which we mentioned before, but most of the scientists, doctors, and the scientific community in the United States does use the metric or SI units. So we're actually using two systems of measurement, which could confuse the picture a lot of the time. SI units are known as International System or System International. And again, it's used throughout the world, and typical measures include the meter or kilogram for weight or mass, and other units which we're going to use in ham radio very, very frequently. The unit of power is called the watt, and the unit of energy is called a joule. So why use the SI system, or why use the metric system? Basically, because it's a lot easier. So as an example, which notation is simpler? So 31 meters, or the equivalent of 101 feet, 8 and 17/16 inches. So the latter is significantly longer to say, it's significantly longer to write, and try to do math on the second line of the customary units versus just using 31 meters to do simple math or calculations with. You can see which system is going to be easier. Another example, 12 inches is equal to 1 foot. So there are 12 inches in 1 foot. And in 1 mile, there are 5,280 feet. So there's some degree of remembering things. We all can remember that there's 12 inches in a foot, but sometimes it's going to be a little more difficult to remember that there's actually 5,280 feet in 1 mile. The unit of distance in the metric system is the meter. So 100 centimeters is equal to 1 meter. And there are 1,000 meters in 1 kilometer. So it just increases by a factor of 10. So this is a lot more simple than remembering 12 inches in a foot and then 5,280 feet in 1 mile. Another example is the freezing point of water. So this is going to be based in temperature units. So the freezing point of water is 32 degrees Fahrenheit, as we all know and have memorized. And the boiling point of water is 212 degrees Fahrenheit, which many of us may or may not know. So those are two distinct, relatively different numbers to remember. They're not easy to come up with off the top of your head. But if we look at the metric system or the SI units, the freezing point of water is 0 degrees centigrade or Celsius. So 0 is, in my opinion, a little bit easier to remember than 32 degrees Fahrenheit. And what's the boiling point of water? 100. So 100 degrees Celsius or 100 degrees centigrade is the boiling point of water as opposed to 212 degrees Fahrenheit. So for centigrade or Celsius, freezing is 0, boiling is 100. In the customary US units, 32 is freezing, and 212 degrees Fahrenheit is the boiling point. So which of those is going to be easier to remember? The latter is going to be easier to remember for me, at least. So you will need to do some conversion from the common system to the metric or SI units, and these are some good numbers just to remember. So 1 foot is equal to 0.305 meters, or it's easier for me to remember that 1 meter is equivalent to 3.28 feet. So that's going to come in very, very handy when we do frequency and wavelength calculation. So you're going to be using that number frequently. So that's a good one to remember. 1 meter is equal to 3.28 feet. And scientific community, 2.54 centimeters is equal to 1 inch. So a little over 2.5 centimeters, or a little under 2.5 centimeters, is equal to 1 inch. And 1 pound is equal to 0.454 kilograms. Or something easier, at least for me to remember, is that 1 kilogram is equal to 2.2 pounds. So we're going to cover metric prefixes. And these prefixes in this slide are going to be larger than 1. So we're going to use the watt as an example. The watt you're going to be using frequently in your amateur radio career. So 1 watt is equal to 1 watt, but how much is 1,000 watts? So 1,000 watts is known as 1 kilowatt. So kilo, and is written with a small lowercase k, is going to be equal to 1,000 watts. Or we can even write that as 10 to the third power. So it's 10 times 10 times 10 is 1,000 watts, or 1 kilowatt. So what if we have 1,000,000 watts? What's that known as? So 1,000,000 watts is known as a megawatt. So it's written mega with a capital M. So that's equal to 1 with not 3 zeros, but a total of 6 zeros. So 1,000,000 watts is equal to 1 megawatt, or 10 to the 6th power. So what if we have 1 billion watts? So 1 billion watts is known as a giga. So giga with a capital G is equal to 1 with lots of zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or this is 10 to the 9th power. And the last prefix we're going to cover is tera. So tera, hopefully you're never going to get larger than a terawatt, but maybe in the future. So tera is a capital T, and that is equal to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 1 trillion. Or written in more exponential scientific notation, that's 10 to the 12th power. So we have kilo, 1,000 watts, mega, 1,000,000 watts, giga is 1 billion watts, and a terawatt is 1 trillion watts. So what happens when we have units that are smaller than 1? So for this, we're going to use distance, and specifically the unit of distance we're going to use is the meter. And in engineering notation, we commonly deal with groups of 1,000. So it's either 1,000 up or 1,000 down. So 10 to the 3rd power, 10 to the negative 3rd power. So the next unit of measure below a meter for engineering and amateur radio purposes is going to be milli. and that's denoted with a small m. So there are 1,000 millimeters in 1 meter, and 1 millimeter can be written as 0.001 meter, or 10 to the negative third power. The next unit down is micro, written with a funny shaped U or mu, and that is equal to 0.0000001 meters, or 10 to the negative sixth power. Next unit down from there is nano, and that's denoted with a small n, and that's going to be equal to 0.1234567 and 1, and that is going to be equal to 10 to the negative ninth. And the last one we're going to cover is pico. So this is going to be, you may run into this with picofarads, which is a unit of capacitance. So pico, and a small p, and that is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. And now I'm going to get confused with the zeros, but let's see how many more zeros are there at the end. And hopefully that's going to be right, and that's 10 to the negative 12th. So 1,000 millimeters is equal to 1 meter, and 1 million micrometers or micrometers is equal to 1 meter, and 1 billion nanometers is going to be equal to 1 meter, and 1 trillion picometers is going to be equal to 1 meter. Okay, now that we have the basics down, we're going to start some examples. Okay, so let's start off with converting meters to millimeters. So what if we have 0.00254 meters? So how many millimeters is that? So for this, you just have to, so millimeters is going to be a factor of 1,000 for meters. So all we need to do is move the decimal place over 1, 2, and 3 to this place and put a new decimal place in that location. So 0.00254 meters is going to be equivalent to 2.54 millimeters. I'll write that a little bit neater so people can see that. So in our next example, we're going to convert something to microvolts. So this number of 0.0000194 volts is definitely awkward to write and probably more awkward to say, but we want to express this term in microvolts. So we remember that micro is 10 to the negative sixth, so we should change decimal point by 6 places. So let's start off with the decimal point here and go 1, 2, 3, 4, 5, and 6. So the new decimal point is going to go right there. So we can express this as 19.4 microvolts instead of the awkward number above. Okay, let's take a current example with amps. So let's say we have a current rating or a current value of 0.07 amps. And amps is a measure of current, or how quickly electricity flows through a conductive medium. So let's say we want to express that in milliamps. So we remember milli is a factor of 10 to the third, or 1,000. So we can move the decimal place from here, 1, 2, and 3. So we'll stick a little 0 there to make things easier. And that's going to be expressed as 70 milliamps. Okay, another example, we're going to go back to volts, but this way we're going to go the other way. Instead of less than 0, we're going to go greater than 0. So this is going to be an easy one. So 1 kilovolt is equal to how many volts? So kilo means what? 1,000. So 1 kilovolt is equal to 1,000 volts. That is the easiest example we've seen so far. So here we're going to introduce a unit we haven't talked about yet. This is going to be the hertz, and we'll get into this in later lectures, but essentially the hertz is just a unit of frequency. It's how many cycles per second something goes through. So if we have a 600 or 6,500 hertz signal, how can we express that in a little easier way? So we can express this in kilohertz. So let's move this by 1,000. So kilohertz is a factor of 10 to the third. So if we take this and go 1, 2, 3, we can see that this is going to be equivalent to 6.5 kilohertz. So I'm going to use that same example and do it a different way and introduce you to a way of converting units that's going to be easier in the long run. So let's take that same number, 6,500 hertz, and we want to convert that to kilohertz. So let's put some parentheses around this, and this is the notation that we're going to start to use. So how many hertz in 1 kilohertz? So there's 1,000 hertz in 1 kilohertz. So we want the units of kilohertz up here. So this is the unit we're going to want to end up with, kilohertz, and we know that there are 1,000 hertz in 1 kilohertz. So we can see that the units cancel. There's hertz over here and there's hertz in the bottom, so you can actually cross those out, and then you just divide 6,500 by 1,000. So what does that equal? That equals 6.5. But what are the units? What are we left over with? So we crossed out hertz on both ends, the top and the bottom, the numerator and denominator, and we're left with the units of kilohertz. So this is what we need to express this as. And that's your answer. Okay, on to a little more complicated way of doing things, but it's actually going to be easier to remember in the long run. So let's say we have that 3,840 kilohertz, and we want that value in megahertz. So we can just kind of know that there's going to be 3.84 megahertz in a kilohertz. But how do we actually get there? How do we actually kind of derive that? So let's go backwards and do it the long way. So parentheses 3,840 kilohertz. And we know that in 1 megahertz there are 1,000 kilohertz. So the units cancel out, numerator and denominator. So it's 3,840 divided by 1,000, and you're left with megahertz on the top, or the numerator. So that's going to equal 3.84 megahertz. Okay, let's do it the longer way, and which will provide a little more detailed of a description. So let's go back to 3,840 kilohertz, and let's say that we remember how many hertz there were in a kilohertz. So in 1 kilohertz there are 1,000 hertz, but we still want to get to megahertz, so we've got to remember how many megahertz there are in a hertz. So actually we got to remember how many hertz there are in 1 megahertz. So we know that there are 1, 2, 3, 4, 5, 6 hertz in 1 megahertz. So we can see by the equations here that the units cancel out. Kilohertz, kilohertz, and hertz cancel out with hertz over here, and then we're left with megahertz. So you can put this all through the calculator, but you can also start crossing out zeros. So the zeros up here, cross that out here and here, because there's 3 zeros here. And all you really need to do is divide 3,840 divided by 1,000 to come up with the same number of 3.84 megahertz. So there are 3 different methods of doing this. One, by just kind of looking at the top equation. The second way is by understanding or knowing how many kilohertz are to megahertz, or if you forgot that, you can go back to the basics and just remember how many hertz are in a kilohertz and how many hertz are in a megahertz, and do it the long way and get to the value of 3.84 megahertz. Okay, we're going to deal with one final example here. And let's say we have 1,432 megahertz. And we want to express this in gigahertz, right? So let's do this a long way. So we have 1,432 megahertz. And we know that in 1 megahertz, mega meaning million, so that's 1, 2, 3, 4, 5, 6. We have 10 to the 6th power, and we can cross out megahertz right here, and you're left with hertz in the numerator, so you have a very, very large number. Then we have to convert it to gigahertz. So hertz is still in the numerator, and we want gigahertz in the numerator here. So gigahertz is going to be up here, and we're going to have hertz down here, so they cancel out. So how many in 1 gigahertz, how many hertz is that? That's going to be giga, meaning billion. So we have 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So we have 1 billion hertz and 1 gigahertz. And the hertz are going to cancel out here and here. And we can do the multiplication and division. But if we want to simplify things, we have 6 zeros up here that will cancel out with 6 zeros in the denominator. So the equation is going to simplify to 1432 over 1000, and that is going to equal to 1.432 gigahertz, because we're left with gigahertz in the numerator, and all our other units, megahertz and hertz cancel out. So that's what we're left with. Okay guys, that about wraps it up. So in today's lecture, we reviewed US customary units versus metric or SI units, and have discovered that metric units and SI units are going to be much more useful for your amateur radio career than the US customary units. They're going to be more easy to deal with. And we reviewed common equivalents in converting feet to meters and meters to feet, as well as converting weights, pounds to kilograms and kilograms to pounds and so forth. And we also focused primarily on prefixes. So SI units of prefixes going from larger to smaller. If we want to get larger than 1, we start off with kilo, go to mega, then to giga and tera. And these are all factors of 1,000. So kilo is 1,000 times greater than a unit of 1. Mega is going to be 1,000 times greater than kilo, and so forth. And we also discovered that we can go the opposite way, get smaller and smaller and smaller below 1. So we start off with milli, and then get smaller by going into micro, get even smaller by going into nano, and then get even smaller than that by going into the value or prefix of pico. And again, these are all by factors of 1,000, so just remember that, and you shouldn't have too much difficulty. And finally, we went through several examples of how to convert between the different prefixes, and we also demonstrated how to do some kind of basic math and conversion by preservation of units, which will come to be extremely useful later in your ham radio career. So thanks again for listening to the lecture, and have fun, and we'll see you at the next lecture in 73. And if I did not mention it before in the introductory lecture on amateur radio, 73 is a common way of saying goodbye or best wishes. So 73, and see you at the next lecture.